Okay, here we go. Today we are going to go over our counting rules. Okay, so this should be a refresher course for you. All right, so the first thing we're going to talk about is the fundamental counting principle. If A can occur n number of ways, and event B can occur n number of ways, then the ways that A and B can occur is n times n. Remember, we always have to talk about it generically, and then we'll go to an example, and we'll say, oh, this makes so much more sense. Okay, so event A can occur so many ways. Event B can occur so many ways. If I want to see how many ways A and B occur together, then I multiply those two numbers. Okay, let's look at an example where we can figure out what's A, what's B, what's N, what's N. Okay, we're going to make a sandwich at a sandwich shop.
I'm done making sandwiches. Forget that.
We have 5 different types of bread, 4 different cheeses or the option of no cheese, and 4 different kinds of meat. How many different sandwiches do you really have to choose from? Okay, so we're going to say, well, I need bread. How many types of bread can I choose from? 5. And I need cheese or no cheese. How many options are there? 5. And I need some meat. 4. How many different sandwiches can I make? We have 100 different sandwiches that we can choose from. Okay. Now, if you're like me, you're kind of picky, so really, some of those 100 sandwiches you wouldn't choose anyway, but there are... Probably not. But good try. Okay, so we have our classic sandwich example for the fundamental counting principle. We also have our classic license plate example.
Yes.
Okay. Nebraska license plates consist of 3 letters followed by 3 numbers. Okay, in Omaha and in Lincoln, right? How many different plates are possible if repeats are allowed? Okay, so we have, this is what I like to do to help me out. We have 3 letters followed by 3 numbers. How many different choices do I have for my letters? 26. And repeats are allowed. So each letter I have 26 choices. Followed by 3 numbers. How many digits do we have to choose from? 10. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 10 choices for each number. So there are my choices for each spot. We're just going to multiply those together. Yes?
And if repeats aren't allowed, doesn't it go consecutive?
That's my next example. Yes. What's this number? Very large, yes.
17,576.
Should be 17 million, right?
Oh yeah. Well,
Okay. Yes.
So do you multiply them all together or multiply the first 3 and then add the
we multiply all of them because we want a number and a number, or a letter and a letter and a letter and a number and a number and a number, and we think and we can multiply, right? Okay, now Noah foreshadowed this. Repeats are not allowed. So our 3 letters, we have 26 to choose from first, but then what? 25 because we've already used one, and then our third letter, 24 because we've already used 2. And then our numbers, we have 10 numbers to choose from in our first spot. We've already used 1, so now we have 9, and we've already used 2, so now we have 8. So we multiply all of those choices and we get still a lot of choices, right? Do we have enough license plates for Nebraskans? Okay, I think we do. Especially since, children can't drive, so we're only talking about adults. We'll have plenty. Now, what do we need to take into account, though? All right, now, are repeats allowed on Nebraska license plates?
Yeah.
They are, right? However, you're probably going to need to take out some 3-letter combinations, right? Because you don't want anything inappropriate landing on your license plates. So, yes, there are 17,576,000. However, some of those we're not going to use because of the combinations of letters, right? So we're going to have to take them.
Actually, it's pretty fun. That weren't even, they were just by chance. I love them.
All right. How about this one? I like this problem. And you'd be able to wrap your head around this problem. How many batting lineups are possible on a baseball team? There are 9 players. If the pitcher cannot bat in the first 4 spots. So we're talking about like a National League team here. Hold on, what? It's a tweak of a permutation. Okay? Because, we have 9 spots in our lineup, correct? 1, 2, 3. The pitcher cannot bat in the first 4 spots. So how many choices do I have for my first batter? 8. My second batter, my third batter, and my fourth batter. 5. Now, here are my first 4 spots. My pitcher was not allowed to bat, but now he can bat. So how many players do I have to choose from here? 5, because now we can have the pitcher. And then next, now we have 4 players to choose from the bat, then 3 players to choose from the bat, then 2 players, and then only 1 player left for the last spot. Okay? So how many lineups are possible? Is this what you were trying to say? Okay. 201,600. That's a lot of lineups for just 9 players, right? Especially with the restrictions right in there. Okay. Just think about the possibilities. How many baseball fans in here?
I like watching it, but I don't follow it.
I don't know what people I don't play anymore.
All right. Now, Jenna was asking if this was a permutation. Let's talk about what a permutation is. Okay. Permutation, order matters. You guys remember doing permutations last year? Okay. If you have, this is how, okay, you guys all know where it is in your calculator, right? Okay. let me tell you how your calculator comes up with that number. If you have n permutations of r, then it is taking n factorial over n minus r factorial. That is how your calculator finds it. Okay? This is where order is important. Okay? How many different seating charts could Mrs. Homan make for this class? Okay? How many people are in this class? Keep in mind that two people are gone. So we have 1, 2, 3, 4, 5 tables of 4 and 1 table of 3. So how many people are in this class? What? 23? $23 factorial is how many different seating charts I can make in this class. Why? Okay? If I switch Josh and Chase, is it a different seating chart? Yes, technically, not by much, but it's a different seating chart. Okay? So when I go to make my seating chart, I start at the first desk, and I have 23 students I could place at that first desk. Okay? Then I go to the next seat, and now I have 22 students I can place there. And then the next seat, 21 students I can place there. All the way down to my last seat, I'll have 1 student left. Okay? So a permutation is a type of fundamental theorem or fundamental counting principle. Okay? But it's special. Okay, 23 factorial is the same as taking 23 permutations of 23. Okay. Now, what if I wanted to take this class and I wanted to make a president, vice president, and secretary for the class? Okay. Is order important? Yes, because Emma being the president is different than Emma being the secretary, right? Okay, so we can think about this a couple different ways. All right, I have a president, vice president, and secretary. How many options do I have for a president? 23. And how many options do I have for a vice president? And how many options do I have for a secretary? 21. Okay, you can think of it like this, or you can think of it as 23 permutations of 3. I'm taking 23 people and I'm choosing 3 where order is important. Okay, so what is this number? Do you know how to work your permutation button? Okay. 10,626. I hear a lot of whispering. Is there a question or are we okay? Okay. I want you to tell me how many different ways are there to arrange ABC? There are 6. ABC, ACB, BAC, BCA, CAB, CBA. Okay? How could you come up with 6 numerically instead of writing them out to count? Okay, there's 3 letters that we're putting in 3 places, right? 3 times 2 times 1, right? Okay, Now, what about mom? Distinguishable. So, OMM and OMM, those aren't different, are they? So I only have 3 distinguishable permutations, right? Because they repeat, since I have a letter that repeats. Okay. So how do you think we come up with 3?
Because then, they're twice, and you can't tell the difference between one and the other.
Okay, good. So what we're going to do, how many ways are there to arrange 3 letters? Right, which was 3 factorial. Now, I have a letter that's repeating twice. So I'm going to have to divide by that permutation because the order of the M's doesn't matter since they're identical. So that is how we come up with 3. I want to know how many distinguishable permutations we have with the word banana. So how many ways can I rearrange the letters in banana? It doesn't matter if it's a real word or not. Okay? So how many letters are in banana? Okay, so there are 6 factorial different ways to rearrange banana. However, we have some repeats. What's repeating? We have the A repeating 3 times, so the order of those A's doesn't matter because they're all the same. And we have the N repeating twice, so since those are identical, those aren't going to matter. Okay. So, let's see, we have 6 times 5 times 4 divided by 2. This is without my assistance, I would like you to tell me how many distinguishable permutations we have of the word papillion. Alright, how'd you set it up, Chase?
I had 9,
Factorial.
factorial times 2, factorial times 2, factorial.
Good, and what does that give you?
I don't know my calculator's there, so.
Oh, that's not good. Can somebody help Chase out? $45,360. Okay. Does everyone agree? Is everyone okay with how to work their calculator? Okay. Let's talk about a combination where order doesn't matter. What are situations where order is not important? What? Okay. Anytime we're talking about a permutation or a combination, you're taking a certain number of objects and you're picking them, and either the order is important or not. Okay? So like with our seating chart, I was taking 23 students and placing them in 23 seats where order was important. Or I was taking 23 students and picking 3 of them to be president, vice president, secretary. Order was important.
Or if you just choose 3 people to be at the top of the class, be like,
Okay, very good. Like maybe a committee,
yeah.
right? All right. How many ways can I choose a 5-person committee from this class? Okay, so on a committee, is anybody ranked higher than the other? No, you're a committee, you're all equals, right? So order is not important. So if there's 23 students in this class and I am choosing 5 of you to be on a committee, order is not important. How many ways?
33,600.
33,649. Still a lot of ways. Right? Okay. So there are 33,649 different 5-person committees that I can make. Okay. Now, if order was important, would that number be higher or lower than this? Find it. Find it. Find 23 permutations of 5. What is it? It's higher, okay? Because if I have 5 people that make my committee, all right, when I say order matters, the order of those 5 people gives me more options. Right? Okay. Look at another example. How many different ways can I put 5 Titan basketball players on the court if there are 15 suited up to play? Let's not worry about what position they're really supposed to play, okay? I have 15 basketball players suited up. I want 5 on the court. How do I do that? Okay, 15 combinations of 5 because the order is not important. It does not matter if Nate goes on to the basketball court before Bradley. They all go out there together. Okay? What's this number? 3,003? I'm going to form a 12-person swim team from 10 boys and 15 girls. How many different ways are possible if I want 6 boys and 6 girls on my team? Okay, let's digest this. What are we working with here? We have boys and we have girls, right? We have 2 different things we're worried about. So let's talk about the boys first. How many ways can I pick 6 boys? Okay, I have 10 boys, and I'm going to pick 6 of them to be on a team. Order doesn't matter because they're all equals on a team. Okay, let's talk about girls. How many girls? Okay, I have 15 girls. I want 6 of them to be on the team. Order's not important. So now I have boys and girls. What do I do with those 2 numbers? Multiply them. We have the fundamental counting principle here. I want this many boys, and I want this many girls. How many different ways can I make a swim team? And what? Questions? and get to this answer with their calculator? All right. Here is your homework. And you have some time to get started.